Okay, hello everybody. Thank you so much for being with us today. I'm Mohammad Tehrani and would like to welcome you all in the first session of the second edition of Water Whispers Wednesdays webinars 2025. Um, as you know, after 1 year of our program, this is a sharing time which is planned to be held a couple of times during the year for sharing the hydraulics and water relevant issues. For those sessions where the speaker will attend in person, the webinar will be conducted in hybrid mode. And unfortunately, this is not the case this time. Each session will feature dynamic presentations lasting approximately 30 to 40 minutes, followed by an interactive 20 minutes of Q&A session. Before we dive into a talk, quick reminder to please stay engaged with us. Feel free to ask questions using the chat box, and we will address your question in a dedicated Q&A session at the end, or you could turn on your mic and camera at the end and ask your question or share your comments directly. Today there is no exception, and we will have a distinguished speaker who will share his expertise on harnessing Oman's coastal wave energy, a pathway to a sustainable renewable energy future. Whether you are a pioneer, senior professional, or just a young beginner in this area, get ready for an engaging and informative session. Let's, without any further ado, to introduce our esteemed speaker for today, Dr. Mohammad Niku, Associate Professor at Sultan Qaboos University since 2021. He is awarded as Elite by Iranian National Elites Foundation since 2008, and he is recognized for his contributions to water and sustainability. Listed among the world's top 2% scientists by Stanford in 2024. He is ranked also among the Oman's top civil engineer, and he received the Oman National Research Award 2024. Formerly an associate professor at Shiraz University, he earned multiple distinctions, including top young researcher since 2018, and Iran's Eminent Young Scientist Award in 2020. He has been an honorary visiting fellow at the University of Technology of Sydney since 2022, and Dr. Niku has supervised 11 PhD and 45 master theses and published over 190 peer-reviewed journal papers with 85% in Q1 journals. His research boasts 5,373 citations and an H index of 41. Since 2021, he has pioneered transformative projects in Oman, leading an HM strategic grant to enhance reservoir water quality at Wadi Daya. If I'm wrong, I hope I will be right. Then, through innovative interventions, as co-principal investigator, he contributes to a flash flood early warning and monitoring system in Al Batina. He also collaborates with the FAO Oman on climate change impacts and promotes renewable coastal energy solutions. His expertise spans machine learning, data science, renewable energy, and integrated water management. Mohammed, thank you so much for accepting to be with us, and floor is yours.
Thank you so much, Dr. Tehrani, for this opportunity. And hello, everyone. I guess now you can see my screen, true, Doctor?
Yes, perfect. Now we have received your screen, perfect.
Yeah, thank you so much.
Go ahead, please.
Thank you. Hello, everyone, and I'm happy that today I can talk a little about the coastal wave energy, and especially about harnessing Oman's coastal wave energy. That is the goal and pathway to a sustainable renewable energy future. As Dr. Tehrani kindly introduced me, I'm Mohammad, Associate Professor at SQU. You can easily scan this hologram and find my details and so on that I will pass in. Okay, nowadays, ocean energy is a renewable resource that harnesses the power of various ocean-based systems to generate clean electricity. This presentation mainly explored the approaches to integrate this technology, especially wave energy, for maximizing the efficiency and contributing to net zero emissions, as this kind of renewable energy are clean and they will not produce any greenhouse gases. As all of us know, we have different sources of energy in oceans, including wind, wave, tidal energy, and thermal energy. The majority of the audience here are students or faculty members who engage in this kind of thing, different aspects. My expertise mainly work on the wave energy assessment. So today we'll explore the utilization of the ocean energy systems and how they can pave the way toward net zero emission. And our focus in this talk will be a summary of three of the studies that I did in 2023 and 24, and about is centered about the technologies, especially multi-body wave energy converters, or we call it WEC, as all of you know, and their optimization for sustainable energy solutions. My research lab members in Oman mainly focus for sure in Sea of Oman and a little bit on Persian Gulf as well. In Sea of Oman is a region that it has a wave energy potential, and it has a unique climatic and wave condition that makes it ideal for innovative ocean energy system, particularly multi-body wave energy converters. However, it should be mentioned that the models that our lab members, my talented student work, are not just, we can use it and they are adaptable for any regions. To be more familiar with the study area of the couple of work that I recently published, it's about in close to the Riyadh and Muscat. Muscat is the capital of Oman, almost in the middle, or I can say. And these figures and this matrix is extracted from my talented student Ali Reza Shadmani, that now he's in Belgium for a PhD student that work on wind turbine. He worked with me in this study that published in a prestigious Renewable and Sustainable Energy Review journal. As you can see in Oman, especially around Muscat and Riyadh, we have 3 buoys. And based on that, for example, one point we extracted this matrix that show the energy period and the vertical line significant wave height, the frequency of happening. For example, 4.94% of the waves will have the energy period of between 15 to 16 seconds, and also the height between, for example, 2 to 2.5. So on average, based on this matrix, you can see, because during the time of the year, we have different wave height and wave period, and in all the studies, normally we maximize the annual wave energy. So wave energy is more predictable and more dense compared to the wind turbine. Sometimes less cost as well. So because of that, now there's many companies around the world, including Webtas, Hovercraft, and so on, these 2 companies and other companies working on this era, because for the same square meter, we can obtain more energy through the wave, and also wave are more predictable. So because of these 2 features, many scientists all around the world, including in Iran, also in other places, work on the wave energy. This is the specific multi-body wave energy converter. As you can see, we have different rotors, for example, the right side and left side, and there's an angle between these 2 that can be opened and closed, especially during the storm. It can be closed to reduce the load on the structure. It's very, efficient Webtas, and we can design it in a way that capture all the wave conditions. Some wave energy converters, or we can say WEC, just work on a specific situation, but Webtas somehow design in a way that it can capture majority of the range of wave height. This is the references that I extracted these 2 figures. I consider this video because it's very useful. I'll play it to see the details about the Vectors.
The WebTOS wave energy converter delivers a stunning performance. With a high efficiency and optimized use of construction materials, WebTOS produces energy at a very low cost, making it a competitive contribution to global energy supply. Key to the technology is the design of a self-buoyant rotor, which transforms wave energy into rotating motion. The movement is controlled solely by the balance from ballast, which is more than half of the total weight of the rotor. Offering peak efficiency at almost 100%, the rotor delivers energy through a simple and reliable drive system that ensures energy from any movement of the rotor. This energy is transformed through one-way rotation of a common axle. The rotors combined create a smooth and constant delivery of energy to the power generator. With a speed in the same range as that of wind turbines, WebTOS is able to use exactly the same generator technology. The floating wave energy converter is positioned by a strong mooring system, which can be easily installed at almost any depth. As the mooring is particularly designed to be flexible and allow full rotation, it secures a maximum production no matter the direction of the waves. Depending on the weather conditions, there is a great variation of energy from waves. WebTOS deals with this by changing the angle and the corresponding width of the wave energy converter. Therefore, the power to the generator is optimized to a much broader range of wave conditions, allowing a larger benefit to its annual energy production. The closing of angle in the system has also proven its superior effect in extreme weather conditions by minimizing forces on the structure. Without the need for extra strength to survive storms, costs are kept as low as possible. Access to WebTOS is safe through the calm area behind the wave energy converter, since the energy is removed from the waves. Inspection and maintenance can be carried out in a wide range of weather conditions. The WebTOS wave energy converter is scalable and adaptable to all wave conditions. WebTOS technology is efficient enough to exploit the enormous resources in wave energy. This has been proven through extensive research and development.
Okay, as you could see in this figure, why I utilize the Vectors company, because they claim that they can harness the energy for any kind of wave height, and in Oman, especially northern part, we do not have a appropriate wave height, but in the middle, because of effect of Indian Ocean, and in the south because of the Arabian Sea, because it's close to the open ocean. It's not like Persian Gulf or Sea of Oman. In the southern part is connected in the south to the open sea. So in the north we have this issue that wave height would be 1.5. It's not even 2 meter. I mean the average during the year, not in monsoon season. Also, during the monsoon, northern part, we do not have so much wave height. For example, in the south of Oman, in Salalah, we have 4, 6, 5, sometimes 3 to 5, 6 meter. But at the same time, in the north of Oman, we have 1.5, maximum 2 meter, because of, for sure, it's not connected to the open sea. So we need to, and all the studies that until now, to the best of my knowledge, is only work on experimental. All R&D, including Vectors company, is pure experimental. So we need to utilize optimization. We need to use numerical model to be able to optimize the layout. As you can see, it's kind of layout, a couple of, we call it farm in the technology. So Multi-body wave energy converters, or multi-body WECs, are cutting-edge system engineered to harness wave energy through interconnected floating structure that you saw in previous video, and also the real scale that implemented by WebTOS company. This design optimized energy capture by leveraging the relative motion that you saw in the video, that rotors moved and then they can easily move by any kind of wave. This is offering superior efficiency, enhanced survivability, especially as you saw and watched and listened in extreme condition by closing the angle between two arms, or I can say legs, not arms. So it can be adopted for various wave regime, especially for Oman, because we have monsoon is very important. However, as I mentioned, despite these advantages, their advantages, these systems come with some challenges. Modeling and optimization will be rigorous and will be time consuming. We need high computational resources and extensive simulation time. Why? If you see these rotors, for example, these are not like one body. See, couple of rotors. I'm not sure that you can see my mouse or not, but in a couple of rotors installed on one leg and another leg. So all of these should be numerically simulated. So in my lab, there is one person expert in boundary element method that I'm not expert on that, but I'm expert in data science, optimization, and internal things that he was in charge to simulate, and the computational burden was so much with the HPC for sure, not with normal computer, the HPC that I have there. So as you saw in the video, we need to select the layout, and layout should be optimized to be able to maximize efficiency and also operational viability. The arrangement of this device so need to be optimized, and normally we use optimization algorithms that map the variable space to objective space. As you can see, these red points are non-dominated solutions that compared to the blue dots are better, especially if two objectives are minimization. Normally in optimization algorithms, if we have one objective like energy that should be maximized, we can multiply it by one negative sign and then minimize it again. So the lower points are dominant, are optimized. We need these kind of points that show which layout can harness more energy. In this figure, we can elaborate it more. For example, consider we have 3 WebTOS. Every WebTOS have 5 rotor. In this study, we couldn't utilize more rotor because of computational burden. Now I'm ordering one HPC that hopefully I will receive it by next month. Then we can increase the number of rotors to 10 and to be able to simulate a larger scale, not just 3, 1, 4, 5, 6, 10, 20, and so on. And we have a plan for utilizing the AI, not ChatGPT, artificial intelligence like machine learning, to be able to reduce the runtime. So objectives would be maximizing the power absorption, as you can see, and also by minimizing sufficient separation distance. Why sufficient? Because if the VEX, right, the X divide between these 2 points, we have a Y and X. If they are too close, as all of you know, or my colleagues know, we have destructive behavior. If they are too far, also we will not harness energy enough. So it's kind of optimal place that, so we consider this is a sufficient separation. It shouldn't be closer than this one or smaller than this one, and this should be minimized as much as possible during the appropriate length. So in this study, we utilize the unified NSGA3, UNSGA3, and AGE multi-object evolution algorithm 2 algorithms. And as far as you can see here, from 2 criteria like hypervolume, the more the better, it shows we reach the more space in the objectives, and inverted generational distance, IGD, the less the better, it shows that we reach the better optimal solution. In both, we can see that the AGE perform better and it's converged better. From this one is smaller, from the hypervolume, as you can see, the AGE is better. And so we select the adaptive generative estimation, AGMOE2, for the next stage, because it can converge sooner, as you can see here, and also it can be also more efficient as well. So I just consider 4 figures out of all results just for elaboration. The papers are published, and you can easily send me an email. I will share it with you. And majority of you, as a student, as a colleague, you already work in this era, so it's very, easy for you to go through this process, and you know better than all these details. As you can see, for example, for UNSJT Unified and AG, you can see, for example, for Q factor, almost same, close together, and also separation distance same. We have 2 layout triangular, and also we have for another separation less, we have 2 layouts. So the model in the first stage give you some idea. Okay, in this place between Muscat and Warrior, you may need to put it next to each other with the distance 100 meter. Okay, and also you can choose another layout like triangular. How we can choose? We have a different Pareto optimal solution that you need to select it based on decision maker idea. As you can see, we have different solution. Every solution have different distance and different energy absorption. Then the decision maker will be decide based on the available budget and so on, and different criteria. They can select which solution would be better. Although all of you knows that all the Pareto optimal solution are optimal, and we can use it. Do just if, for example, consider that we optimize the layout, done, everything is done, we do not need to change the device orientation or the opening of the legs angle. No, it's not enough. We need to think about efficiency. So we consider 2 objectives to do the dual approach. First approach, we optimize the layout. Then for the optimized layout, we need to consider 2 new objectives: total load on the structure, and net power absorption. This dual approach ensures not only optimal energy can be extracted, but also minimize the wear and tear on the structure, enhancing durability. So we need it because such adaptability is particularly crucial for maintaining efficiency, because in this device, when we have an extreme situation, the waves can damage the structure. So if we can optimize the orientation and intelligently operate the VEX from the coastal area without going to the sea, would be much better, because the efficiency in harsh and unpredictable marine environment like monsoon, even in Oman, is very important. So in our study, we introduce operational optimization for first stage, layout optimization, second stage, operational optimization. That normal, this is the routine in the coastal engineering people. But what is not routine is about optimizing layout and orientation of this kind of X with this approach. That's play an important role in ensuring that the VEC will work reliably, especially under changing wave conditions. So we consider the legs angle to be matched based on real-time wave scenario. And our target is to reduce the hydrodynamic forces and increase the net power. What we can do, I put some results from the study of my lab members that, for example, for HS, different CS state, for HS 0.75 and TP 8.5 to same HS, and what I just increase the period. So for every CS state, the decision maker knows that the optimization model in the second and dual system in the seconds run, and the trade-off between net power and the average total force. So we can for sure less HS all same. So when TP is less, we have more force. When TP is more, here we have less force. For sure, it's very clear. And also it's very clear as well that when wave period is less, we have more wave in less time. So the net power is almost the maximum of the trade with 170, and here is 90. So this kind of graph give either the decision maker, okay, if they put it, what we are doing with our team, we consider a sensor on the WebTOS based on Internet of Things, a new area that my students work on that, to be intelligently operate the WebTOS farm, wake farm. It's not just wake one wake, for example, 10, 20, to be optimize the orientation and angle. And in this case, no need any technician to go there and just open and close, because it's very time consuming and boring. So they can, based on the wave height condition, they can open or close. For any kind of graph that you can see here, the angle also optimized, and we do not have time to enough time to go through all the details. But through this multi-stage optimization for varying C state that you saw in the previous slide, not just one HS for sure, we have different HS. For example, you can discrete it between 0.75, 1.75 to, for example, 5.75. This is based on the wave height that you have in your study area. For example, in one area, you have between 0 to 2 meters. In another area, you have between 0 to 10 meters. So it's varying. So for different HS, you can obtain some solutions. For example, for HS 0.75, then 1.75, then to 5.75. For sure, is a net power, different TP. And also in the next graph, you can see the average total force. For sure, when the wave height will be increased, therefore we have more force. In low wave height, like 0.7, we have a less force. How we can use this one is because we know we have too many points. So we need something to give us an idea. Okay, if the wave period, TP, for and what I have anticipated, what variation in the net power as well as the load, the structure will be anticipated to be faced. So we can have a better arrangement. So you can see the range, yeah, because we have different point, not one point. So on one TP and one HS, we have variety of the range of this. When the TP will be changed, for sure, by increasing the TP, you can see 8.5 to 13.15, 14. The gain restart from 8.5. It's not increasing. So increasing, and from a smaller value to larger value. Then we have more TP, for sure, the load should be decreased. That you can see is the graph is valid. So we double check the result in way as well. So for varying the C state, our results show that remotely controlled based on Internet of Things, although we did not introduce this concept in these studies, we are working with one of my talented students in University of Tehran. So we are working on significantly reduce the force on device and intelligently manage the WebTOS form for long-term durability. Future work is about considering fatigue and economic factors, and also, as I mentioned, fast and scalable AI-based model to reduce the runtime is very important for us. And about the study area, we are doing our team. We are working on a good project now in the south and in the Sur region about because it's close to the south part of the Oman. So we are trying to do the techno-economical assessment in eastern part that also affected by Indian Ocean. This is the graph that I wanted to discuss with you. All of you knows that we need the data. So in Oman, like other part of the world in the Middle East, you have a little bit lack of data. So what we are doing, especially Sultan Qaboos University, they provide for us some kind of ADCP that all of you knows. 3 ADCP, and also we have a plan to buy another one. So acoustic Doppler current profilers plus the available buoys of the ministries and also the ports like Sohar port, like Salale port, especially Sohar port deploys some buoys and also wave measurement system. And our team also utilize a little bit satellite-based product, I can say reanalysis data like Aero5, like other, I can say stuff in Iran University of Science and Technology with one of my colleagues, Dr. Siadat Musavi. We are working on estimating the wave height based on with another team that we have based on the satellite data. It's very useful because, deploying the ADCP, as all of you know, is very time consuming and also costly, and the device is expensive. After the data, we need to process the height, period, and direction, and then based on the available information about peak period and average significant wave height, we can decide about our work. So in any as wave energy implemented, we need to consider at least these 6 criteria. First one, all of you know, consistent. So we need to have a good wave height. In Oman, we have a monsoon, and also good place, because all of Oman is surrounded by water. So it's good resource. Wave pattern, for sure, all of you know, we need to consider the peak, the seasonal change of wave pattern to see when the webtas or any kind of energy like point absorbers, like the other stuff like floating device, hovercraft device. We have many wave energy converters that we need to technically and economically assess them, that we have planned to do it in near future, inshallah, hopefully this year. And high efficiency, high energy wave climate in Oman, we have it in the south and also in the middle. And more important of all of this is energy diversification. Why? Because it helps diversify Oman energy portfolio. As you know, the energy price is very expensive in all around the world, including Oman. And reducing dependence to fossil fuels and mitigating the impact of oil price is very important, as well as, for sure, mitigating the greenhouse gases that we have it here. So greenhouse gases, by this kind of renewable energy, it can reduce and can mitigate the climate change effect, and it can help us to enhance grid stability, because no ocean is a consistent power source. And it's not like solar or wind. Wind, if we have a two-speed in the winds, I'm not expert in wind turbines, but maybe you are. And as far as I know, we cannot operate them in any kind of extreme events. And solar panel during the night is done. Although they are building some batteries, but batteries are expensive, and it's not in a larger scale, at least until a couple of months ago, implemented. So we need, if also the wind and solar is good, we need to have an ocean wave energy as well. So we need to have all of them, solar, wind, and wave energy, and depend on the efficiency and how much cost they have. So another things that we are planning to do, I'm trying to I did my best to just talk about future, the thing that we are planning to do and we are doing right now, not just the result of some couple of studies that my lab members did. So environmental impact assessment, because when you deploy any device like VEX, we need to see that marine environment will be affected. Hydrodynamic sedimentation is as close, but sometimes it's far. So marine environment should be considered. Pathway of the ships, you need to be careful about that one as well, and also some kind of fishermen are there. So we need to consider all of this, and grid connectivity, economic feasibility, and so on. So preliminary studies that our team did indicate that with appropriate technology and investment, wave energy could play a vital role in Oman energy mix, because from north to south we have an ocean, and majority of the cities are close to the ocean in Oman. This is the figure about Oman Kossori. As you can see, from north, Mosandam is close to Hormuz, and from north Mosandam to the south here in the Salale. In this figure, you can see better from Mossad is belong to Oman, Mosandam, then enter to the Emirates, and again enter to the Oman. So Oman has some place, these strategic places belong to Oman, then here is Emirates, and then enter to the Oman. So Sea of Oman, Arabian Sea, and Persian Gulf. You can see here is connected to the open sea. As you can see here, Toosi University did some measurement by Dr. Ahmad Sana, our senior faculty that already retired. He was expert, and he is expert in coastal engineering, one of my best colleagues that I ever seen. And he, with the help of Toosi University, they deployed the acoustic Doppler current profiler ADCP in these points and measure the wave height and period. Although in 3 places, Sur, Ras Al Had, and Al Ashkara, they did not deploy any kind of ADCP, and these 4 points also we do not have any measurement during the monsoon. Why? Because during the monsoon normally is the summertime. Yeah, in the monsoon summertime, Salalah is a very good tourist attraction place in the summer because it's very the rain happening there, very beautiful. At the same time, we have a long wave height, so we have a higher and more significant wave height. As a result, it can damage any kind of structure, even the ADCP that you deploy in the bottom, for example, 20 meter, 15 meter, 25 meter below the ocean. We have to install the ADCP, and this ADCP should be mooring strongly to be able to anchor it in a rock to make sure during the waves and so on, or fisherman events, you cannot take it. So this is our plan. So first objective, as I mentioned, is that we have a plan to conduct field measurement by ADCP, and then we want to develop the more calibrated SWAN model by connecting SWAN to Python and gather all the data to be able to, in a calm situation and extreme situation, calibrate the model in the best possible way, because we want to give the accurate result. It's not just a paper, is applied research that we need to give where is the hottest spots, which technology is better, hovercraft is better, WebPlus is better, which one point absorber is better, which technology in every single part of Oman would be better for harnessing the energy, and in every part, where is the optimal hottest spots. At the end, objective 4, we can obtain the atlas of wave energy. So all of you know about ADCP, no need to mention me. So mentioned we need to do the site selection and mooring to the bottom of the ocean, and then normally every 3 months we will go and take it because we need to change the battery, and we will use it for statistical analysis. This is the very simple video all of you knows about the ADCP. That is work based on the sending sound waves, and as you can see here, this ADCP emits high frequency sound waves or acoustic pulse, and based on that measure the wave height and wave speed and so on, direction and so on, wave period and direction. And last things that I want today to present is from this reference. It's just a video to show how divers dive to the ocean and change the ADCP, and how it's very crucial for our research, the field data mirror. We cannot rely on the satellite at all. We need to have a ground-based measurement. I guess not ground-based, and ocean-based measurement. Is from University of North Carolina, although it's belonged to many years ago, but it's okay.
On June 4th, 2009, the UNC Coastal Studies Institute, in conjunction with UNC Chapel Hill's Department of Marine Sciences, performed maintenance and replaced oceanographic equipment in the water located just offshore of Kill Devil Hills, North Carolina. UNC CSI divers replaced an acoustic Doppler current profiler, or ADCP, which provides current and wave speed and direction as part of a nearshore processes and beach hazard study. The goals of this collaborative project are to explore the impacts of nearshore currents and waves on beach morphology, and to pinpoint specific local conditions that result in rip current formation. UNC CSI divers removed the ADCP, which has been deployed since last summer, and replaced it with another loaded with fresh batteries. Once at the lab, researcher Greg Dusek will download the data from the ADCP and use it to ground truth and improve models used to predict rip current formation, a valuable tool that could be used by area lifeguards, such as the Kill Devil Hills Ocean Rescue, a local partner on the project. Not only does the equipment provide valuable data for scientists, it also provides habitat for a variety of marine life. Sea stars, urchins, and barnacles cover the pod, while fish, such as triggerfish and sheephead, make use of the available food and shelter. The project includes data collected from 2 ADCPs mounted in the seafloor less than 1 mile off Kill Devil Hills, regular beach profiles used to map changes in shoreline, and rip current observations made by KDH Ocean Rescue. The results of this project will help us improve our understanding of surf zone processes, such as rip currents and strong shore break events, through the analysis.
As you can see, installing this device is a little bit hectic because you need to, anchor it or open it or bolt it somehow. So it's difficult, need professional people. And thank you so much for all of you for your attention. And now I guess I have to give the floors to Dr. Tehrani to discuss about the future event on 7 May 2025. And this is the figures that I extracted from them. And Dr. Ehsan, I guess, will be 7 May. So all of you can attend. And this is the time. Doctor, please.
Thank you so much, Mohammad. As a first and foremost, thank you so much for accepting to be with us, and thank you also for this enlightening presentation. Before going to introduce our next event, because now it's time for Q&A session. So let's see first if we have already some questions or comments from the audiences. You could write it down in the chat box, or you may raise your hand and ask your question or share your comments. Please, is anyone from the audiences, if you have any comments or question, feel free to share with us. Okay, perhaps if it's fine, perhaps sorry, I could start with asking. Perhaps you have already mentioned it, and perhaps I missed it. Just wondering, because you mentioned about the WebTAS and told us that you have chosen it because they claim that they will have some better, let's say, solutions for that. Was there any competitors or competition between the companies that you have chosen for your project?
Dr. Tehrani, it was not a project on that time that I studied these kind of WebTAS, but WebTAS, they claim that they have a more efficient system and it's logical based on their rotor. And the thing is that hydrodynamically it can has more durability because the WebTAS legs can be closed during the extreme events. And more important, and the third, I can say, a reason is that they can harness energy for more range of wave height. I communicated with this company, but they did not share the details of their design. For sure, is confidential. But I designed it, and I showed them that we can simulate very well the things that they are doing experimental.
Okay, thank you so much. I have other questions, but because now we have some audiences like Karim and Izad. Go ahead, please, Karim. Karim, go ahead, please.
Maybe his mic is locked and he cannot talk.
I think now all the audiences have the access to the microphone and camera, so Karim, you could just turn on your mic. Yeah, now we can hear you a little bit, not that strong, but yeah.
Okay, sorry about the quality. That's the internet. We always know.
That's much better. Go ahead.
I want to know a little bit about the cost, like maintenance cost, installation cost, and how can we compare it with like offshore wind turbine or something like that. My second question is, if these turbines or if you have it there, is there any plan for saving it, like with hydrogen or something like that for the future, and how they save the electricity or something like that? This is my second question. The third, I think you touched it a little bit about like storm and how resistant these are to the winds and hurricanes, and what do they need to like make them so strong against like hurricanes or something like that. Is there any specific, I don't know, structure or something like that? That's all my questions. Thanks. And it was a great presentation. Thank you.
Thank you so much, Dr. Karim. What I can say is that the company unfortunately did not share with us any kind of cost, although in the SQU, in the Sustainable Energy Research Center, with Dr. Saleh and I, we have a plan to communicate with them, not just for this kind of wave energy converter. As I'm sure you already know about that, because your field also is coastal. So we have planned for the project ongoing. I mean, it would be maybe next couple of months we'll receive the final decision about the project. If it's implemented, then we need to communicate with them. In this study, we did not include the cost, but this is the claim of the company, but they did not share any information about us. Although we can simulate somehow, estimate, but it's not accurate about especially maintenance and maybe deploying the device. The second question that you mentioned, it seems I'm getting old, I already forgot it, but Dr. Tehrani, some people like me looks young, but they already absent-minded. So the second and third one, I guess the
I'm
second one,
much better.
yeah, third one,
It was
I
about
remember
using the hydrogen.
About
If you
the
will have,
transferring.
and storing
Oman
the
has a
resources.
plan. Yes, Oman has a plan. I mean, they already invested so much in the green hydrogen, but as far as I know, in Salale, hovercraft company already for free deploy one hovercraft N class. Although I'm not sure that it would be great for Oman wave height or no. Doctor, you know that the Karim, that for every wave energy converter, we need to study it first by the local data and simulate and optimize, but they didn't do any of this. They even do not have the wave data, so our craft deploy that, and they have a plan to utilize it somehow in green hydrogen, although I'm not expert in green hydrogen. My colleague Dr. Saleh mentioned in the research that we have one person as a scientist in the Sustainable Energy Center that is expert in green hydrogen. So maybe they will think about how they can connect to the grid the electricity that will produce, for example, for producing green hydrogen or any kind of things, or even connected to the grid. But until now, there is nothing on the ground except hovercraft N-class 1 that they deployed. And one of my bachelor students also have an idea to somehow improve their efficiency by some, I can say, small idea about the design. The second question that Dr. Karim, you have already forgot it. Can you mention it again? Because I guess I remember about what structure. A structure, yeah.
Exactly. And during the storm, yeah.
This is again the second, in this study, that in the last three papers that I work on, point absorbers and WebTOS, and another paper that it's under review with my student in the University of Tehrani, we did not consider the fatigue and so on. So we just simulate the force, and my student did it. But about the structural durability, we need to have the real scale, detail, and dimension. And details of this, they never release it, for sure, because this is their technology. I remember 2 years ago when I want to study the WebTOS, my student communicate, and they said it's confidential. So what we can do for this kind of thing, just by numerical simulation, somehow roughly say what's the force and so on. But about the structural point of view, that is not my field. Maybe you are expert on that. The design with the legs and opening and closing the angles, and the opening, like perforated breakwaters, you see they are perforated, so the waves can easily go inside and go out, although it's reduced the wave transfer and also wave reflectance because of this is obstacle, but it's perforated. Remember in your study we work on this, so they can somehow say that the structural force will be minimized, and this is true. Like a sphere one is very strong. Any kind of waves can go up and down. This is their claim. All the good point that Dr. Karim, you ask, is that all the wave energy converters company claim that their work is the best. This is the final thing that I understand. What is the there's a way to go. I mean, many research we can do on implementing and estimating the real cost of deploying and maintenance. It's a good topic of the research, but we have a limited. We need to find right person for doing this kind of research.
Thank you so much, Mohammad, for addressing these 3 questions, which were the nice questions from the
very
side.
good.
We have already,
because Dr. Karim is exactly in the field in hydrodynamic simulation. So he knows better than me, especially he is expert in computational fluid dynamic, because I reviewed some couple of his work before. He's expert in computational fluid dynamic, and honestly, I'm learning from him. Yeah.
Okay. Actually, we have some comments. Ehsan Kazemi, who will be our next event, let's say, a speaker, wrote that I need to hop onto another call now. Thank you for a fantastic work and an excellent presentation. Then Mahia Hosseini wrote that thank you for your presentation. I have no idea about how much this idea cost, but I want to know in how much range of significant wave heights the cost and energy received is efficient. And then she continued, and are the WebTAS durable in extreme event condition like tropical storms and tsunamis? I think that the second question you have already touched with the Karim question.
This is their claim, but we need to, I can complete this answer that we have a plan to simulate the WebTAS during the Kharif season. We call it Kharif, is a monsoon. And tsunami, we do not have so much tsunami in Oman, honestly. We have just monsoon events that based on that, we have more significant wave height. We need to simulate it because we cannot for now bring a real scale because it's 10 meter by 10 meter and they will not provide it for here unless the Minister of Energy ask them to like hovercraft to deploy that. For all of these questions, we cannot answer 100% correct because we need to we work on the Muscat right now. Now we have planned to deploy it in Sur. For example, the main place of tsunami is south of Oman in Salale. And we need to have all the data, ADCP and calibration and so on to be able to answer this question that the thing that they claim is really work or not.
Thank you so much for addressing these comments and question as well. Sahar Davari wrote, thank you, Dr. Niku, for your presentation. I guess she didn't wrote any question or remarks anymore. Well, Mohammad, as we have missed your camera, I guess. Just please check it. Is there any comments or questions from the audience? I know already some of those who are very interested and eager students. Yeah. Karim Alizad. Okay, go ahead, Kalim. I think he has some more comments.
Sorry again. I just remember something that I'd like to know about. Sure. Was there any study about wave climate change based on the climate change that it will have in the future and sea level changes and how these devices could be optimized to better work in the future with the future wave climate?
Yeah, thank you, Dr. Karim. One of my talented students, Ali Reza Shadmani, he's in Belgium. He worked on somehow obtaining the wind direction and wind speed during the climate change and try to simulate it by simulation, the effect of climate on the wave height by changing these two parameters. But as far as I know, it's not 100% complete. And about sea level rise, I did some studies about seawater intrusion, not just for the wave energy converter. For wave energy converters, if it's in float, the sea level rise, I guess it will not be very important. But as you correctly mentioned, climate change is very important. So one of the student that we have is exactly work somehow close to this idea. But it's a good topic, because as far as I know, one of my students work on just estimating the ADCP wave height based on the satellite data. Another one work on climate change on the not on the ocean. So the thing that about the climate change I did, it just was very simple, just effect of the climate change on wind speed and direction, and then we entered the vectors of wind into the SWAN model. We did not study the in depth the climate change as a good to do, the good things to do. I guess many also scientists work in this area.
Okay, I think that Karim already have taken the appropriate, let's say, answer about this question. Yeah, no more comment, Karim. We have just a few minutes, if any. Yeah, okay, good. We have just less than 2 minutes or something like this for any other question or remark from the audiences. I see that Yasser Rostami wrote, thank you. And Mahia again wrote that, thank you for your answer to my second question. I want to have the sense of cost of this technology compared to wave height and the amount of power energy we can receive to evaluate in Iran. Can we have this system in the Caspian Sea, or I think it's or instead of the Persian Gulf?
I think, Doctor, for the Caspian Sea, I'm not sure, because it's not open sea. For Persian Gulf, also look like the north of Oman is not too much. Maybe in the Sea of Oman, because it has two areas, Iran and Oman. Maybe Sea of Oman is a little bit better. About the cost, as I mentioned, the company did not provide anything, and we are not the builder of the system. So because of that, I couldn't include the cost, as Dr. Karim also mentioned. Maybe investigating about cost of maybe designing this kind of things in Iran is much easier than communicating with the company, because they will not never release this kind of information about their design method. Maybe about the cost, they will give you how much they will sell it to you. It's not exactly the cost they build.
The cost of the fabrication.
Exactly.
Yeah. Okay. Then Mahia said, thank you. Okay. So I think with that, we could conclude the session. Again, first and foremost, I really appreciate the Mohammad for accepting to be with us and sharing his insights and the experiences on the topic. And we have already introduced our second event for the 2025. So please stay tuned with us. We will write more on the LinkedIn account, and also we will share the recording of this session on the Apparat and YouTube channels. So feel free to rewatch it or share it with your friends or colleagues. So with that, I mean, before we wrap up the session, I want to extend my big thanks and appreciation to all the audiences. The good questions that we have received from your side. So please stay engaged with us and stay tuned. And thank you everybody for participation in this session. Now I would like to ask everybody who would like to turn on your cameras so that we can take a group photo of this session. Yeah, this is our custom, and we do it every session. So please feel free to turn on your camera so that we could take a group photo. Any other comments, Mohammad? Until that we will receive the picture of our audiences.
No, thank you so much. Thank you so much. I appreciate all the questions and our respective audience and colleagues that ask very constructive question. Although I know almost majority of them, and I found new of them also. Hopefully, we can engage together and work together in the future.
Sure. That's right. I think this kind of events could be a ground for future collaboration. So I hope that it initiates something. Yeah, we have the lots of talented students who are eager in doing the projects. So I think that would be a really good opportunity. Yeah. Okay, we have already some joined, let's say, our audience to us. Perhaps we will wait a couple of seconds, and then I will ask Mushtaba, please, to make a, let's say, group photo or a snapshot. Yes, we count. 3, 2, 1. Perfect. Okay. There are some others who are joining us. Perhaps we could wait some more seconds. Mohammad would like to go to the gym, and I already promised him to be, let's say, very very restricted with the time. Yeah, I think I have already. Do you have me, or I have out of this session? I think. Okay, now I'm coming back. Okay, so now most of, yeah. Okay, still there are some guys. If you would like to join us, please do it more quickly. Yeah. Okay, now I think that's much better. Okay, Mustafa, please go ahead. 3, 2, 1. Okay, with that, thank you so much. I appreciate it and wish you a nice afternoon if you are in Tehran.
Goodbye.